So I hope the last video was clear to you guys. So in this video, I'll start by making a basic blockchain function and adding some simple prototypes to it. So first of all, let's start with creating so this is the main file in which we'll be doing all the work. So let's start by creating a function blockchain, and we'll just have two variables in it right now. This dot chain, it will be an empty array, and this dot new transaction, this again will be an empty array, new transactions. So the role of these two variables will become clearer to you as we go on. But so just to give a heads up on what it is. So basically, also there is another way we can write this in JavaScript. That is, we can write a class of blockchain, and we can create a constructor in which you can pass on this dot chain and this dot new transactions, like this. So this is also a good way of doing, but we'll be following the other approach as mentioned. So I'll just zoom it in a bit so that it's easier for you to view. Right. So after that, as soon as we have created this function, we have begun the process of building our blockchain data structure. So basically, blockchain is an immutable data structure per to say, or a database. So it holds your record of all your transactions, and it's basically a digital ledger which is distributed, and it is immutable. So immutable means it cannot be tampered with. I'll show you how it works later on as we go on to the proof of work method and so. So first of all, the first thing that the first function that we require, the method that we require, and this is the create new block method. So how will that be defined as blockchain dot prototype dot create new block. So this will be a function that so right now this function will take in some inputs, like one will be a nonce. I'll explain what nonce is again. Previous block hash and hash. Alright, so let's just say we create a new object here now. The constant new block is equal to an object, and in this object we'll be having an index. This dot chain dot length plus 1. So as you can see, we have index which is equal to this dot chain dot length plus 1. So this dot chain is our total blockchain right now. So as you can see, for the first time it will be empty, but as soon as we start creating new blocks, it will start building. And so index will be the last block in the chain, and plus 1. So this new block will have an index of the last index. Then we'll have a timestamp which will just be date dot now. Then with that we'll have transactions. So when we create a new block, a block in the blockchain is created to store transactions in it, right? So to store transactions, so this we have created this. So as I said, we have a new transactions array again here that is empty. So basically, what this array is these new transactions are all the transactions that have not yet been verified and put in the blockchain, right? So we'll add all the new transactions that have not yet been put in a block, and this will create that for us. And after that, we'll just have a nonce that will say nonce. So nonce is a property parameter that, so let me just come up to a nonce and explain what a nonce is. So when I'll be going through proof of work, I'll explain it in more detail. But basically what nonce does is, it is basically a number that we brute force to verify the new block. Alright, so this just shows that we have created the block in a legitimate way. Next property we'll be adding is a hash, and that will again be equal to hash, and we'll add previous block hash, and that will be equal to previous block hash. So basically we have this three parameters in the new block that we are taking up in an input to this new blockchain, new block in the blockchain. So these both are hashes, right? So what a hash is, again, this will come up later as well when we'll actually create this hash. But hash is basically an encryption of a kind which cannot be, reverse tracked. So once you create a hash, you cannot go back to, suppose there's a word Kush and I create a hash of it, it will give me a random text. So suppose I have Kush, it will give me a random text, something like this. But if I have this random text, I cannot go back to Kush, the word I encrypted it with. But if I have the word, for example, Kush, and I again create an hash, the hash will always be equal to what was generated. So I'll explain it again in detail later words. But so this was a new block object that we'll be adding to the chain. Alright, so as I mentioned that this.new transactions were all the transactions that have not been verified and added to the chain. So by doing this, by creating a new block object, we are adding these transactions to that block, and now we want to clear up this transactions as we have already added all of these in the blockchain, right? So this will clear all the new transactions for us, and we can just add this dot chain dot push, and we'll push in the new block in the chain. Now as soon as that is done, we are basically done with the work of this prototype function, and we can just return our new block that we created. I hope this seems clear to you guys. If not, now I'll explain it more. So now we go into the test.js file of ours, and we have to test whatever we made. So first of all, let's just export this module. So I'll write module.exports is equal to blockchain, and I'll go to the test.js file, and I'll create a new variable called blockchain, and we'll require it from that file so that we inherit all the properties from that file, and we get that function. So basically this requires our blockchain.js file. Let's create a new chain of ours, so we'll call it Bitcoin, and this will be equal to new, and we'll create a new blockchain. I hope this is same, that this thing you understand, because this is similar to values Kush is equal to new user. Okay, sorry, new user. We did this in the first video, and I guess this is the same as doing that. And then we'll just console.log Bitcoin. So let's just run this for a while. So I'll go to node dev slash test.js. So as you can see, it returns as a blockchain object with chain empty and a new transactions array empty. So let's test the new create new block function. So we'll just add bitcoin dot create new block. We'll pass in nothing for now. We'll not pass anything for now. And as you can see, as we run it again, we get an index of 1. We get a timestamp we have no transactions, we didn't pass nonce hash and previous block hash. So I'll just pass those as well. Let's pass the nonce as 2343, and then let's pass a random hash, and let's again pass random hash. As you can see, this is the previous block hash and this is the current block hash. This is random for now, but we'll be creating functions to generate these as well. So as you can see, now we have a chain which has an index 1 and this. So I'll just create some more blocks in it. So shift. I'll create some more blocks. I'll change the numbers. And I'll change the text. And as soon as I changed it, and now I'll just again run this. Now as you can see, our chain is now populated with 1, 2, 3 and 4 blocks. So we have a block with index 1, we have a block with index 2, we have a block with index 3, and we have a block with index 4. And all of these don't have any transactions yet, but we'll be adding those as well. So let's now create another function that is required. So that is blockchain dot prototype dot get last block. So this function will enable us to return the last block in our blockchain chain. So as you can see here in the chain, the last block is index 4. Now why do we need this last block? I'll explain it later. But we need to have a function that will return us this last block. So in this function, I'll just return this dot chain dot length and -1. Sorry, this dot chain. This. So as you can see, this will give us the last block in our blockchain. So I'll just save it and we can test it out here. So I'll just have 2 of them, and I'll do bitcoin dot get last block. Let's run it. We need to return this, and right. So it gives us this return. I'll just console.log this. So as you can see, this is giving us this last block, that is index 2. As you can see, the chain we have index 1 and index 2. And this will be giving us index 2 with the timestamp of this and this. So our get last block function works. Right, now let's create another prototype that will help us in adding new transactions. So again a function, and this will take up some parameters at the amount, sender and recipient. So as I said, blockchain is a storage of a distributed ledger. So in a ledger we add transactions, and a transaction has 3 basic parameters to it: the one who is sending the transaction, the one who is receiving it, and the amount that is being sent. Right, so so this will take in the amount, this will take the hash of the sender's address, that is, and this will take the recipient's address. So let's just create let's just create a new transaction block, and in this we'll add the similar thing, amount. We'll add sender as sender, recipient recipient. and we just need to, so this is the new transaction data, and we'll be pushing this data inside the array that we created. So this dot new transactions dot push new transaction. I hope this is clear to you. So let's again understand what this is. So what it will do is this will create a new transaction between this sender and this recipient, and this will add this to this array that contains all the pending transactions. So as soon as you create a transaction, it will get added into the pending transaction. That's how Bitcoin works. So if you create a Bitcoin transaction to say that suppose I am sending one Bitcoin from my address to someone else's address. So first it goes and gets added to an unverified transaction. Then it takes some time to verify it. The verification process is done by proof of work, which we'll come to later. And as soon as it is verified, it calls this create new block function that will create this new block with the transactions added to that block, and then again it will empty it. Alright, so this is the create new transaction function. So we can call it, so let's just rename these for making it much more easier to understand. We'll call it pending transactions. Alright, pending transactions. So let's just test the new function that we created. So I created this new block, and now I'll create a new transaction. So Bitcoin create new transaction. I'll add 100, and I'll add an address, and I'll add another address, and I'll just run this function. So as you can see, alright, as you can see, we get the index 1 that we have, this create new block, adds a transaction, has an array in its transactions property, right? So that means that our transactions have been added in it. Alright, so we have this array. Now if you want to look at it more closely, so I'll just do bitcoin.chain and we'll do this, and let's again do this. As you can see, as you can see, we have the transaction added here, which is amount 0, sender and recipient. So that is how you create a new transaction, and it automatically gets added as soon as you create a new block. So as you can see, in this block we have this transaction added, but we don't have this transaction in the index 2 block because it gets cleared out. Alright. So if we have another transaction out here, let's just copy this down, and this transaction is of 200. Let's just save it, and again to go. As you can see, now in my blockchain we have 3 transactions. One is amount 100, one is amount 200, one is again amount 100. So that is how it works. So this is created a basic blockchain for us. Alright, so in the next video I'll cover hashing, and I'll cover how do we actually add data and how do we verify the data. Alright, so this was creating the basic blockchain, skeleton. In the next video I'll be hashing the data before putting it, and I'll be creating a proof of work algorithm. Thank you.